Okay, guys. Here we go. So for tonight's homework, we're going to be working with both equalities and inequalities. So the question you're going to have to ask yourself is it an inequality or is it an equation? So let's get started. I want you, and what we want to do, we're giving you graphs. I want you to graph this one. I want you to graph this one, this system, and this system. So the first thing I want to do here is I want to get y by itself. Okay? So two or three ways to, there's more than one way to do this. So I'm going to minus 2x and minus 2x, okay, from both sides. Getting a little sloppy here, sorry. That's terrible. Come on, Sterling. Okay, so now I have negative y is equal to negative 2x plus 6. How do I get rid of that negative? Well, there's a couple ways. One way is I can multiply everything by negative 1. And I mean everything. That's why I put parentheses around it. I could have divided this and divided this and divided this by negative 1. I could have added that y over. There's multiple ways. But negative 1 times y, negative y is positive y. Negative 1 times negative 2 is positive 2. And negative 1 times positive 6 is minus 6. So here is my manipulated equation. I have a slope of 2 over 1 or negative 2 over negative 1. Why do I always do this? Well, because this is telling me 2 up and 1 to the right. This is telling me 2 down and 1 to the left. Okay? My y-intercept is 0, negative 6. Okay? Now, we can write it as y-intercept as a coordinate, or we could say b equals 6. I don't care. You're telling me that you know what you're doing, whether you do it as a y-intercept like that or b equals 6. Negative 6, Sterling. Okay, so what I'm going to do is I'm going to count down 1, 2, 3, 4, 5, 6, and that's my negative 6. Now, I'm going to count up 1, 2, and right 1, and I can keep going in the up direction all I want. I could have also gone down 2 and left 1. I just want you to see that all those lines line up. All those points line up. Now, take your straight edge. And in this case, there's no ambiguity. There's no, hey, is it dashed? Is it solid? It's an equality. It's always a solid line, because what an equality means, as opposed to a inequality, is the only solutions to an equality are the points that lie on the line. That's it. Only the points that lie on the line. So for instance, it goes through 3, 0. Okay? Well, that means I should be able to plug in 3 here and a 0 here and get a true statement. Well, do I? I get 0 is equal to 6 minus 6. I get 0 is equal to 6. True. Okay? So that's an equality. That's an equation. Equality. That's what we're talking about. When we say equation, equate, to equate something is to set it equal, okay? Now, here we have an inequality, okay? And it's, right now, it's greater than, I say right now because we got to get this cleaned up. We got to get it in the form of y and mx plus b. And we don't know what's going to be in the middle. But we do know this, it's going to be dashed. How do we know that? Because it's a greater than. If it's a less than or a greater than, it's a dashed line. Okay? So I'm going to minus 2x and minus 2x. So I get negative y is greater than negative 2x plus 6. Uh-oh. So what I'm going to do is just divide everything by negative 1 on this one. Over here, I multiplied everything by negative 1. And I said I could have divided everything, so this time I'm dividing everything. So what we get is negative y over negative 1 is y, but now it's less than. It was greater than, now it's less than. because I multiplied across the inequality by a negative number. Okay, so this becomes 2x and this becomes minus 6. So guess what? It's going to look just like this line, isn't it? It's going to be down 1, 2, 3, 4, 5, 6, and up 2, right 1, up 2, right 1, up 2, right 1. Remember, we do not say over, because over doesn't tell us direction, right? So we line up all of our points that we just made, and I'm okay with that. And then I just make dashed lines, okay? Now, let's go through this like we've never done it before. I'm going to test 0, 0. Why 0, 0? Because it's real easy to work with. I write 0 is less than 2 times 0 minus 6. 0 is less than negative 6 is false. So this is not in my solution set. So what does that mean? Well, that means that I can take, that means that the graph is going to be below, and it is less than, so that makes sense. So I'm going to just put some arrows in here to begin with, but that's what it means. But just because, I'm going to come back and shade it in. And what it means, if we remember, and maybe some of you have been occupied, whatever, maybe not watching all my videos, it means any point in that shaded region will make this inequality true. Any point. So there's infinitely many answers here. And by the way, there's infinitely many answers over here on the equality. This is just a line of points. It seems like this is a pretty good discussion when you get a little older and you get in, take more mathematics. Is this infinity bigger than this infinity? I'm gonna leave it at that. That's just a good, interesting conversation down the line. Now, let's do this one. So notice everything's not nice and clean like it was in our notes for yesterday, meaning that they're not all y's less than or greater than. We got to do some work. So here's what I'm going to do. I'm going to add 2x, and I'm going to add 2x. So y is greater than 2x plus 4. Slope equals 2 over 1, or negative 2 over negative 1. B equals 4. We know it's dashed, and we know it is above. Hopefully you know why I wrote all that. The slope comes from this 2. The y-intercept comes from this 4. Dashed comes from the fact that it's a greater than, and above because it's greater than. Okay? So here I'm going to add 8, and I'm going to add 8, and I'm going to get 2y less than or equal to x plus 8. And then I'm going to come back and I'll divide by 2, and I'll divide by 2, and divide by 2. So y is less than or equal to 1/2 x plus 4. So x divided by 2 means that you're going to take whatever x is and cut it in half, right? Well, what's 1/2 of x? Same thing. But this makes it easier for me to see my slope. My slope is 1 over 2, or negative 1 over negative 2. My y-intercept is 0, 4. It's solid because of the less than or equal to, and it's below. Now I'm ready to graph. Okay, so let's take red for the first one, and we're going to start at b equal 4. 1, 2, 3, 4. Okay, and my slope is up 2 and right 1, or down 2 and left 1. It's dashed, and it's above. So I'm going to go like this, like this, like this, and just make a dashed line off the grid. Okay, here's what I know. I know it's up. It's above. Okay, now I started putting my arrows down pretty quick. Let's check. 0, 0. Plug in 0 here and plug in 0 here. Is 0 greater than 4? True or false? It's false. So 0, 0 is not in this solution set. But I do know this. This guy's going to be shaded above. Okay? Now, let's graph the other one. Let's use orange for this one. Plus 4. 1, 2, 3, 4. They have the same y-intercept, don't they? I'm doing so much talking, I really didn't pay attention to that. Okay? But they do. They have the same y-intercept. And this one has a slope of 1/2. So up 1, right 2, or down 1, left 2, down 1, left 2. Make sure we get enough points for a nice clean line. And it's solid. So I'm going to set up my ruler on my slope. I'm going to draw my line in. What do I know about this one? This one's shaded below. See that? Below, below. Oh, look at where the arrows are pointing at each other, right here. So if I plug 0, 0 into here, is 0 less than or equal to 4 true? Yes. So 0, 0 is in the orange one because all of this below is the orange. So just so you know, this up here is all going to be red. This down here is all going to be orange. Okay? This overlap is where our solution is. See where the two arrows point at each other? Okay? So red true up here, but not orange. Orange true down here, but not red. Red and orange true right here. So that's what systems of inequalities are all about. Looking for the overlap. So there's that word again, overlap. Okay? Big word, overlap. Okay. So in systems of inequalities, we're looking for the overlap. In systems of equations, we're looking for the intersection. So for this one, because it's equals, by the way, that's how I know it's a system of equations. We want the intersection. And if we get an intersection, then we know it's a unique solution, kind of a callback to our previous unit. But we have two other possibilities. So this is one outcome. The second outcome is no solution. And that means the two lines are parallel. They never intersect, remember? Or 3, we could have infinite solutions. And that means that they are the same line. Okay? It turns out that both equations represent the same line. So let's see what we have here. Step 1. Let's write it in slope-intercept form. So add 2x and add 2x. Okay? So y is equal to 2x plus 4. So I have a slope of 2 over 1, and I have a y-intercept of 0, 4. I don't have to worry about dash solid, no above or below. I don't. Here, I'm going to add 8 and add 8. 2y is equal to x plus 8. Divide by 2, divide by 2, divide by 2. Y is equal to 1/2 x plus 4. Look at that. I have the same slopes and the same y-intercepts. Okay? So, I used red for the for this one on the last one, so I'm going to use red again. So I'm going to count up 1, 2, 3, 4, and my slope was 2. 1, 2 up, right 1. 1, 2 up, right 1. 1, 2 down, left 1. 1, 2 down, left 1. More than 3 points, but that's okay. And I did them right, and I know I did them right because they all line up on my ruler. Look at that. Okay, so there's equation 1. Equation 2 has the same y-intercept, only it's up 1 and right 2. correct? And down 1 and left 2, it is a positive 1/2, so I'm in a positive direction. So right 2 and up 1, or left 2 and down 1. And I'm not worried about dashed or solid. I'm just worried about writing out my lines and making sure they go to the right place. So this solution is 0, 4. The y-intercept is our solution because that's where they meet. They meet right there. So in tonight's homework, you're going to be working with both inequality systems and equality systems. Okay? Take care. Until next time.